For our last talk of the morning, we have something that promises to be full of fun and adventure. Please join me in welcoming Christopher Swenson with Colossal Cave Adventure in Python. Of course, this is a Python conference, in the browser.
Yep, that's on. Okay. Like she said, my name is Christopher Swenson, and we'll be talking about Colossal Cave Adventure. So what exactly are we talking about? Colossal Cave Adventure is, I'll get to some of the details in a minute, but it's one of the first text adventures ever made. It's written in Fortran IV for the PDP-10, which was a mainframe, like 1960s and 70s era mainframe. And I wrote a Python interpreter to interpret that. And also interpreted that in JavaScript, but we'll get to that. It talks for everyone. There's not, I mean, there's a lot of code in it, but it's Fortran code mostly, so no one can read it. It doesn't matter. It's like really old Fortran code. It's great. And the slides are available on GitHub. I'll leave that up there for just a second. But yeah, it's on my GitHub. Swenson is my username. Yeah, so some alternative titles for this talk, I thought, is this sort of like being lazy in the hardest way possible, like, which I'll get to exactly why that is. It's also a programming turducken, because there's just so many layers of really awful things put together. Fortran script, or full stack Fortran 4. Who am I? So I'm Christopher Swenson. I'm currently working at Twilio, one of the sponsors. I've previously worked at places like Google and the US government. I am sometimes a BeeWare core contributor. BeeWare is an open source project, and I'll get to that, how we use some of those components in this. And occasionally organize a conference called PyDX, which is a Portland Python conference. Probably not happening this year, but it happens some years. And I like programming and stuff. Like, this is just sort of just random stuff. So the motivation for this was when you start at Twilio, you sort of have to create a project with the Twilio API as your as a starter project, like something you do like your first couple of weeks you're there or something like that. And so I was like, well, that sounds like fun, but maybe I want to do some sort of game. And Twilio's main APIs are like text messaging and voice calls and things like that. And so I was like, I want to make a game with text messages. And like, well, what kind of game am I going to make? Well, obviously, I should make a text adventure, right? Because that's the most straightforward sort of game. But again, I'm really lazy, and so I didn't want to actually write a whole new game from scratch because that just sounds tiring. So why don't I just take the first text adventure ever made and port it into Twilio, and so that you can use it with SMS? And so I thought I would do that. How hard can it be to read some old Fortran code and run it? So that's where adventure comes in, sometimes called Colossal Cave or Colossal Cave Adventure. It is a text adventure written in probably about 1976. The first version we have source code for is from 1977. It was probably the first text adventure. There's some contention around that, but definitely one of the very first extremely addictive games. Like, this is the first time I've ever read reports of people missing classes in college because they were so into a game and stayed up all night kind of things. It was extremely popular and influential. It launched a whole genre of adventure games. And I wrote it I did not write it. It was written way before my time in Fortran IV for the PDP-10 mainframe, like I said. If you want to play it now, you can text that number right there, +1 669 238 3683, and you can play it on your phone. It will send a text message to my server. My server will load up the code and then run it until it outputs something and send you the response back, and then you can play it like a normal game. You can also play it in the browser, and I'll get to how I made that magic happen later, that awful magic. And yeah, and I'll share that link again, but yeah, that's the number. Yeah, it'll probably way overload the server if everybody texts right now because the code is very inefficient, but it works. And so how does adventure start? So typically whenever you start it up, you see this little message here somewhere nearby is Colossal Cave, where others have found fortunes and treasure and gold, and so forth and whatnot. Use commands of 1 or 2 words, these sort of very classic text adventure words. It also, I literally did not change the source code even one tiny bit, so typos and all, and it still tells you to send complaints and suggestions to Crowther, who's a guy named Will Crowther who wrote it back in the 70s. I don't recommend bothering him. He is still around, but I don't think he cares to hear your complaints anymore about this game from 41 years ago. And you can type help for hints, and then it gives you like a little description of where you are, and then you enter in commands and play it. Pretty straightforward. Yeah. What is the PDP-10? PDP-10, like I said, is a mainframe. It's made by the Digital Equipment Corporation. I think the first versions were in 1966 or 67 or so, and then they kept making it for about 15 years or so. So it's very popular. A lot of games, a lot of the first computer games are written on it because it was a big time-shared system that a lot of people could use. And it took up like a whole room. It was a big computer. And Fortran IV for the PDP-10 is like, we're talking like all these classic programmer things that you thought you would never see again, like all caps, everything is all caps. No recursion, you can't have recursion because it doesn't, like Fortran 4 just couldn't do recursion. It just doesn't support it. Indentation is like a doesn't matter. Like you can indent, but nobody did because it doesn't matter. And you'd waste punch card space because punch cards this was still designed for punch cards. Spaces don't matter. Like you can remove every space from the program and it will still compile just fine for the most part. And I think tabs are a little weird, like they're like 6 spaces or something. I don't know, they're really strange. It sort of doesn't matter, but I think there's 6 spaces. And there's line numbers, like you need line numbers to do pretty much any kind of branching logic. Although they are technically optional for everything else. So like, what does this look like? We're going to see a bit of Fortran code now. It looks quite a bit different than I think like we probably are used to seeing any code nowadays, like Python code or anything like that. But you can sort of like see the core programming things there. If a line starts with C, it means the comment, or an asterisk. I think it also works for that. You have like defining some implicit variables. This is all defining variables, although ran, I think, is a random number generator function that's specific to the PDP-10. I couldn't find a lot of documentation on it, so I just guessed on how to implement it. It seems to work. Yeah, you can see like it has multidimensional arrays, and it has line continuations. You see like this 1, 2, 3, 4, 5 on the side there. That means that that's actually one long line that just has all those declarations in it. That's pretty common, and actually, like some documentation seems to imply that that should come slightly before the beginning of the line, but the source code that I have puts it at the beginning of the line instead. So the source code may look like that or like this. It's not 100% clear what it really should look like or what it might have looked like on the punch cards. Column 6, yeah. Well, column 6 is definitely the specification, but it has tabs at the beginning of the source file that I have, and I didn't touch anything, so. But yeah, column 6 is where the code starts. Columns 1 through 5 are the line number. Yeah, things like that. So here's some more setup code. So read the parameters. This is like what like a basic if statement says, like if .any. So this is meant before we had like keyboards like we have today. So you had to do .any dot or .xor dot or .and dot. Like none of this fancy like ampersand character. Those didn't exist yet. So you had to use all that. You had to use GoTo statements if you wanted to do more than one thing on an if statement. And then you had some simple variable declaration, or not declarations, but assignments there. It also supported some really kind of powerful ways of defining like arrays. So you could initialize a whole array at once using this kind of strange slash syntax. And that's kind of cool. You can do simple loops, so it didn't really have while or for, but it had do. So you could just say do, and then you tell it the end line that you want, 1001, and I'm going to execute this for 300 times with I set to that each time, and then you do each of those in turn, and then when you're done, the last line that it's executed will be 1001, and then it will skip to the next line whenever it's completely done. So this is just setting all the arrays to 0. So it's zeroing out everything before it reads in data from a tape. And the way you read in data is you have to do it in 2 lines. So you have read. One is like it's sort of like the Unix, well, it's not Unix, but it's like the file number, like device number or something. So 1, I believe, is tape drive in this particular system. 1003 says you're going to use the format defined on line 1003 and read it into this variable iKind. And the format G naturally stands for integer. So computed GoTo is one of my favorites because it's really just very strange to like our modern eyes, but it like is super convenient for things like this. So what it says is it says take iKind plus 1, take the value of that, and if it's like 1, 2, 3, 4, 5, or 6, or however many that is, then it will go to the line number specified by that index. So if iKind plus 1 is 1, then it'll go to 1100, and if it's 2, then it's 1004, and so forth. So it's sort of like a little quick jump table. That's kind of cool. So reading data can also be pretty complicated. Like, so again, it's that same basic format, but you can also mix variables and like arrays of things, and then specify that I want to read in 1 integer and then 20 ASCII words. And a word is like 5 letters. We'll get to all that. You can do subroutine calling. So subroutines are really strange though. So you don't just pass parameters in, but because of the way Fortran 4 thinks of subroutines, you can also pass things back. So you're calling it with 6510 and then yay, and then yay is actually going to return a value because you're specifying a variable instead of a literal value, so it can return things too. As you can see, here's the subroutine itself. Yeah, it's a little strange. You can also reuse line numbers inside of subroutines, which is kind of confusing, but makes some sort of sense once you get used to it. But you can see it actually assigning yay equal 1 and yay equal 2 and passing it back. You can start to see how like all this is kind of coming together. Fortran 4 is not particularly complicated. I'd say like each piece of it isn't, but it kind of is a mess to read sometimes when we're so used to things like indentation and like loops like that aren't just manually done. Okay, so I talked a little bit about like how there were like 20 ASCII words there. So before about 1980 or so, people weren't really sure exactly what a byte or what a word meant. So it could be 8 bits, it could be 16, it could be 64, are all over the place now. But before that, like DEC was really known for using 12-bit or 36-bit words. And they defined, I think the PDP-10 manual said that a byte is any collection of bits between 1 and 36. So like, I don't know. And they sometimes use 32-bit in like their VAX, I think. So the PDP-10 used 36-bit words, and it did technically come out after ASCII, so it does use ASCII sort of. It's mostly about the ASCII we would recognize today, but it had some weirdness in it. And then they packed it into a 36-bit word, 5 letters at a time, and they had 1 left over at the end, which you can see there's like a little 0 hanging off, but they packed them left to right inside of a word, so you can see how A, B, C, D, E would be packed in. So it also, Fortran 4 doesn't really have types. Everything is an integer, and so even an ASCII word, an ASCII like 5-letter word is an integer. It's just like you're just having shorthand between the two, and so it doesn't really matter what you put it in. You could put it as an integer or as a 5-letter word there. Why does this matter? Well, because Fortran 4 also does not have like a built-in library, and so the code has to actually parse user input itself. And this code is amazing, by the way. Like, I spent a long time like staring at this code trying to understand what in the world is going on, like, and how is this parsing it, and it's really beautiful. I love how quotes indicate that this is an octal number, right? This is something you don't see nowadays. Like, obviously, quotes mean octal, right? And then it goes through and it reads in a bunch of words at a time, and then it tries to split them up by spaces, and you can sort of see like this really strange like shifting mask structure in there. And what I found out what that's doing is it is looking for the ASCII space character, which is hex 20 or so, or 32, I think, is the decimal number. So it's actually like going through like chunks of them at a time and looking for the space character, and then trying to split it based on that. And I could have a whole talk probably just on looking at this function and how just neat it is, and like how like almost elegantly beautiful it is, and completely incomprehensible at first glance. Anyway, so this is one of my favorite pieces of code. It's a little maybe hard to read, but it's just Fortran code. Lots of Fortran. Okay, so that's sort of like most of the Fortran code I'm going to talk about, I think. So give you kind of a feel for what we're dealing with here. And so my project was I'm going to, again, take all this Fortran code, and I just want to run it as is. Naturally, this code is so like in such an old Fortran 4 variant and specifically written for the PDP-10 that you can't just compile it with GCC or F77 or something like that and expect anything to come out. So I had to write a compiler from scratch. which seems like a fun thing to me. So if you're familiar with how a normal compiler would work, you normally like scan the text into tokens. You parse those tokens into like a syntax tree. There's some other talks that have talked about this, I think, this weekend. You optimize the syntax tree to try to speed things up and remove dead pieces and stuff, and then you generate or execute the code. But that all sounds way too hard. Like, I'm doing this for like a fun little work project. I've only got a couple of days. I don't got time for all that compiler nonsense. Like, that sounds like a whole semester's worth of work, and ain't nobody got time for that. So the Swenson general strategy for coding up a really quick and dirty compiler is to split all the lines out, and then you split each of the lines by white space and commas and parens, just using like the little Python split function. Like, we're not going to make this too hard. And then try to just parse that line and then execute it as is. Like, just kind of just hack it until it works. Like, this is a one-off. This is not going to be a general Fortran IV interpreter. This is just meant to run this one program. It doesn't have to be perfect as long as it, technically works. Good enough for me. Whenever writing a quick and dirty compiler, I recommend NameTuple. NameTuple is just your best friend. Like, you can just use it to just quickly generate like a little class that has like a bunch of fields in it. So like every line is either a comment, or it has a label maybe, or it's a continuation line, and then otherwise it just has a bunch of statements on it. And that's all it is. And so I just say I want to create a class that just contains those fields so that I can easily use it and create them and pass them around and things. And ditto for when I go into lexical analysis, I'm going to split them into tokens, and tokens will have like a name and then like some stuff associated with them. And so I sort of build my grammar based out of these name tuples. So like if I have an if statement, it's going to have an expression, and then it's going to have a statement. There's also one thing I didn't talk about much, which is a numerical if, which has an expression, and then it has 3 statements it could execute, or actually 3 labels that'll, depending on if it's negative, 0, or positive. Sort of like the compare operator in Python and other places. There's GoTo, which could have labels and maybe a choice if it's a computed GoTo, and then assignments and stuff like that, and so forth. Like, you can have basically all these different kinds of statements, and I sort of define kind of a really rough grammar that way. Then I have to load the tape drive, because remember, this is PDP-10. Like, it's expecting to have the source code in like one tape drive, and then maybe have the data in another, or something like that, or the binary code in one tape drive and the data in another. So you have to read all that in. And then combine all the lines together, because you have all those lines split out, and there's those continuations, and so you need to make longer lines than your 80-column, punch card could do. And then so my lexical analysis is very basic. I'm just going to give some pieces of it here. So it just goes through and it parses all the lines just using a standard little comprehension there. And then it goes through and checks to see if it's a comment and marks it as a comment, and then kind of ignores it. It checks to see if it has a label, and it marks the label. Checks to see if it's a continuation, and then splits them all back together, and then it returns the line. So very basic, this is a very straightforward way to split things into lines, I'd say. And then it has to go through and do a basic execution. So I kind of like skip almost all the rest of the compiler and just go straight to execution. Like, whatever, don't need all those extra steps. So we go through, we execute the next statement, and then the rest of the logic is basically like if the statement told us to go somewhere else, like a GoTo, or if it ended a loop, like if I'm in a do loop and I reach the last line and I'm done, then I need to like pop something off the stack and then like retrace my steps to figure out where to go next. And then when I execute the statement, I basically just go through and say like, is this an if? And if it's an if, execute it, just done. Like, yeah, nothing too fancy there. Just, is it an if statement? Did it give me a Boolean or an integer argument whenever I evaluate that expression? And just do what it says. Very straightforward. You evaluate expression. If it's a Python integer or Python string, then I just return it as is. And then if it's an operator, meaning like if it's like a plus or an and or an XOR or something like that, then I have to evaluate that. Like I have to convert all strings to decimal numbers and like add them together, XOR them together, and things like that. And the rest of it just looks all like this, like, if it's this operator, then do this, and if it's a next operator, do that. And then I do have to parse the things together so that I can take those lines and make sure that I'm converting them to like the ifs and the operators correctly. And this is all just a bunch of really dirty hacks, just to make sure that it works for this one program and then never again. So like in this case, I know that every if statement starts with if space or if left parenthesis, Like he never uses like two spaces or anything like that, and so I can just write my if parser specifically for this program, even though this would not necessarily work in general. So I parse it, and then I have to match parentheses up to make sure that everything's good, and then I have to check if it's a numerical if, like I mentioned, and then return it. And then the rest of them are all very similar, just a bunch of dirty hacks. So I won't go into all of those. Printing is really fun. So they have a type function, or it's a type statement, I guess. You have to, basically just go through and it gives you a list of things to like print out, and you have to print them out, and it's probably like a variable or like an array of words that you have to print out. I won't go into all that, but you can tell this is super high quality code, because if I find something I don't understand, I print and then I just exit, just crash the whole program. Like, sign of super high quality production code here. There's an outer loop sort of that just executes things just over and over again while it's busy executing. It'll just go in a loop forever. Nothing too fancy there. It does have to accept keyboard input. So normally a PDP-10 was hooked up to a line printer, which was what the type function did. Like when it says type, it means literally type it out onto like a printer. And then you had a keyboard that you would input things into. And so I have a simple little loop here that just converts user input from somewhere into a way that this Fortran code can then read it. It'll look for, see if it needs to assign it to a variable or something along those lines. So we need to have a tape, which we already showed how we sort of load the tape. And then any interface we write, be it an SMS or in the browser, needs to have needs to have an input and output, which are assumed to be connected to like a teletype. So as long as it sort of vaguely looks like a teletype, then it should work. And it turns out SMS looks sort of like a teletype. Like teletypes had like 80 width columns, and you could type in like a line at a time and hit enter. And this behaves almost exactly like SMS does. SMS is actually more flexible. So this is fine. So I was like, okay, I can like write the basic engine, and then I wrote a specific handler for Flask that works on Heroku, and then I can hook that up to Twilio, and then basically it just translates text messages back and forth as teletype input. And perfect, there we go. I also just happened to design it so that the state can be easily serialized, so that you can have each phone number is playing a different game. Like every time you like go in and type something, it'll be like, oh, this phone number has texted me before, so I'll just load up that state, and then they can continue playing where they left off. So you can come back months later and still play the same game. I'll show the little Fastcap now. It's pretty straightforward. It has basically one method, which is that you sent it an SMS. It has to pull apart and see like, okay, who's it from? What did you type? You can't type more than 20 characters because this is a PDP-10. So it just strips that out and converts it to all caps and stuff. Because again, who needs more than all caps? And then it goes through and it checks the database for the state, and then fetches it. It checks to see if you're asking it to reset or quit, because if you get stuck somewhere in the game or you die, then you need to reset and start over. So you have to have a way to do that. So we have to delete the state then, and then if nothing else has happened, then it means we're starting a new game. And so we start a new game by booting one up, and then setting up a new state inside of it, and then again, super high quality code here, just sleeping 1 millisecond at a time until the game's finished booting. Having a nice little while.time sleep there is perfect code. Do that always. And then again, once it's finished spinning up and you give it input, you have to then wait for the game to respond with something. And so you just again wait, time.sleep, it's fine. And then lots of time.sleep, super high quality. And then this is a simple little execution to get the code. Get the state in and out there. So either you're updating it because they just did something, or you're or inserting it because it's the first thing they did. And of course, so again, super high quality code here. The state is just a big dictionary that we just pickle and then compress and stick it in the database. It's fine. Nothing wrong with pickling things and put them in a database and unhandled, user input that we never check for. No, it's all good. Whatever. It's just 12 kilobytes or something, just in a row in a database. There's nothing wrong with that. That's how good programmers program, right? Because that was the sort of text messaging version, was this little Fastcap and stuff. But I wanted to also have this in the browser, because the texting is kind of fun, but it also overloads my server very easily. And so my next step was how can I take this beautiful, perfect code and make it even more beautiful and perfect? And I was I know how. I'm going to throw it into the browser. And how do I do that? Well, BeeWare is a really nice suite of tools that lets you run code, run Python. Its goal, I guess, is to run Python code anywhere. So you can run it in the browser, you can run it in the JVM, you can build GUIs with native look and feels in them. So there's a lot of different components to BeeWare. But the BeeWare piece that I wanted to use was Batavia. Batavia is the component that executes Python bytecode in an interpreter written in JavaScript, so that you can run it in Python you can run it in the browser or in node.js if you want, but generally you want to run it in the browser so that you could basically just theoretically in the future maybe just say like script text equals or script type equals text/Python and just like run Python code and magically it'll work. That's the dream. The ship is sailing towards that dream. Batavia is the name of a ship. There's a funny story behind it that I never remember. It crashed. But yeah, it runs it so there's a Python bytecode interpreter. Basically, it's a re-implementation of the Python VM in JavaScript. And it technically works, which is the most important part. Technically working is the best kind of working. So it just barely works. So there's some challenges, though, to make it work. So far, Batavia is still, I think it's still very early stages. I'm a contributor to it. And it still has some issues, like the first way we designed it, JavaScript and Python concurrency, like don't make any sense together at all. Like JavaScript is like this big callback mess. Like it expects you to like execute a little bit of code and then give something a callback and then it will return. Like, and then you sort of just follow a million callbacks all over the place forever. And that way the JavaScript VM can interrupt you and like switch which callbacks it's executing at various times, and that's how it sort of gets concurrency. And Python doesn't expect that. Python expects to be like running just a big chunk of code and then for the VM to just interrupt it constantly, like without it doing a callback. And the way we did this initially was sort of like we just called Python code like as a JavaScript function, and then that function would just like never return, and so the code would just lock up or seem to lock up, and like your browser would hang, and that's no fun. So I sort of just hacked that to make that work for this talk. Like I figured out a way to add asynchronous callbacks into JavaScript in a way that it technically works. It technically works could also be a title for this talk. Like I said, early stages can only execute bytecode. It cannot parse Python. This, it turns out, is a bit of a problem. But otherwise, it basically works. But if you have the bytecode, then it will generally just run it. Now, there's an exception to this. So, NameTuple, the first thing that I talked about, the sort of core to writing these sort of things, like to build classes really quickly and rapidly prototype. If you were a Python dev, and you thought about, I wonder what kind of master programmer wrote the NameTuple implementation. I have no idea who it is, by the way. I'm not actually trying to say anything about anyone particular. But I would have assumed this is some hardcore Python metaprogramming, building classes at runtime and doing all sorts of wonderful metaprogramming and stuff. And it turns out they're doing it the way that I would do it, which is you just build literally a string that has class such and such, and literally types out all the different fields, and then just runs exec on it. It's no, there's no magic secret here. It just literally writes a Python program with your with a class function in it, and then just calls it. This is the laziest way to do it, but I guess it technically works. So yeah, I was really kind of disappointed in this because it means that I couldn't use NameTuple anymore because I can't use the exec statement in Batavia because we can't parse Python code. Turns out parsing Python code is actually more difficult than executing bytecode sometimes. So yeah, this is a slightly abbreviated version of NameTuple. And it's really fascinating that no, this is not significantly advanced Python. This is a simple template thing. Yeah, I'd say any intermediate Python developer could probably write this. So, yeah, disappointing that I won't be able to do that. There's also some really fun JavaScriptisms. So I love programming WATs, and I'll give you 1,000,000 points if you can tell me what this statement outputs in JavaScript. So if you type this into a browser, don't cheat. What do you think it outputs? And so we have to be able to convert between JavaScript and Python to make this whole thing work. And so what magic do you think JavaScript outputs? Any takers on what it's going to output? 0? I heard 0, so it's going to be false times -1. You'd hope that would be 0, right? Maybe. Or maybe not a number. I don't know. False times something is maybe not a number, right? But would you guess that it's -0? I didn't even know JavaScript had -0. Like that's just a totally new one to me. And so so I had to fix just a bunch of bugs to get any of this stuff to work, because when you go from Fortran to Python to JavaScript, you just get a lot of really weird, messy translation stuff going on. And so, yeah, -0. I had to, it turns out the code did rely on this behavior at some point, and I had to rewrite some things, and it was just a huge nightmare. But it technically works. Got it all to work. You can go to this website here, swenson.github.io/adventure.js, and play it right now. If you start it up right now, do not start it on your phones. It will start spinning up all of the fans in your laptop. It will take 30 minutes to load. It's really great. Luckily, I preloaded it before I got here, and I hope, yes, it's loaded. So it looks like this. It has a little progress bar so you can watch it just chew through your battery life, trying to spin up the Fortran here. It's really cool. But so I got it to start, and you can play it, and it says, "Welcome to Adventure. Would you like some instructions?" See if I can actually scoot that down a little. There we go. It has a little debug console, so you can see each line of Fortran as it's executing it, and it just takes its sweet time. So I'm gonna say, "Yes, I would like instructions." Why? You can see it just chugging through there, trying its little heart out to parse that into some sort of text. It's pretty great. It took me longer to give this. It took me less time to give this talk than it probably did to start up this VM, or this VM within a VM. But yeah, you can see it outputting text now. Is if you need help, blah blah blah. That sort of message we saw from the beginning. So I think the correct thing to do at this point in the game is you enter the building. So you can just type in enter, and then we got to wait a little while because it's has to figure out what you typed and then to try to match it up with its giant list. And it doesn't use any fancy programming techniques like hash tables or anything like that to figure out where you did. So it's just a giant if of every single word it has that it has to check through every single time. So you can really see it going through there. Oh, did we get in the building? We got in the building. So yeah, there's some keys that we can grab. There's a shiny brass lamp there. So we need to take all these things in order to play. So we need to take food, and then again just give it a few minutes to go through. The SMS is actually a little faster because I don't have the extra JavaScript layer of goodness in there, so it only takes about 2 seconds or so to do each of these things, rather than 60 or so that this takes. Yeah, you don't need the food and water till later. I haven't actually beaten this game, but I'm pretty sure you can beat it. There's just enough bugs to get it through. But yeah, no, it's definitely a lot of fun. There are definitely a lot of people playing it because I get thousands of text messages a month still of people playing this game. So that's cool. But I work for Twilio, so it's all free. So text away. And now you can run it for free in your browser. Yeah, so it's going to take a while because it's got to figure out which item you just asked it to grab there. So it's literally going through and checking every item that it knows about in the game. And is it keys? Is it lamp? So forth. And yeah, and that is basically my talk. Fortran in Python in JavaScript. Full stack Fortran IV. I believe we are taking some questions for a few minutes here. We still have a few minutes left. So if you do have any questions, our moderator, I think, will accept those. Yep. I promise you I do not know hardly any Fortran 4 answers. I only knew just enough to get this talk to work. And then I was mission accomplished.
Thank you, Christopher. As he mentioned, please feel free to bring your questions up to one of these microphones. We have a few minutes left.
Hi. A question about the Fortran to Python interpreter. Mm-hmm. In the course of writing a Fortran interpreter in Python, you used as your base case of examination the adventure code itself, right?
Yes.
Did it contain bugs? And if so, is it difficult to disambiguate whether your interpreter is incorrect or the actual code that you're interpreting is incorrect?
So the code definitely has some bugs, and there were some weird syntax anomalies. Like I said, the tab thing being either 6 spaces or 8 spaces, and you sort of were expected to indent each line with 6 spaces at the beginning. The code didn't do that, and I've seen other versions of the code that came later that did do that correctly, and so I sort of had to, I don't know if this is an error in translation, when somebody converted it to ASCII or something way later on they messed up the conversion, but I wanted to interpret the file that I had, so I definitely had to work around the weird indentation issues sometimes, and there are definitely some kind of dirty hacks around things like that in the code. And I know that there are bugs in the logic of the code, although I don't know a super lot about them because this is the earliest version I could find. And so there are definitely like typos and things in there somewhere. Oh, look, we finally got the food. Take water.
Another question I may. So when you were working on the Fortran part, are there any PDP-10 simulators available? And if there are, is it possible to still compile and run this program in the simulator?
I'm sorry, is it possible to run a compiler on what? I'm sorry?
On PDP-10 simulators, are they available? Or?
Yeah, so there are a few PDP like 10, and it might even work on the PDP 6, I'm not sure, because the PDP 10 and PDP 6 are very similar. But yeah, you probably could find a compiler running on those. I know it's very tricky, because compilers are very sensitive to like everything, because they're very complex pieces of software. I did not try to run it on a PDP 10 simulator exactly, but that would be fun, or even getting it to run on an actual PDP 10. I know that there's at least one or two still running in existence. They're kind of, because they're the larger mainframes, they're a lot harder to find in working condition these days, and they're very expensive to run. So yeah, whereas some of like the PDP 11 and other ones like are a lot smaller, and so you see a lot more of those still around. But I have not seen a working PDP 10 in person. I've seen a working PDP 1 and PDP 11. But yeah, it would be fun to run this in a simulator to see if it would compile. I have not tried.
Oh, thank you.
So did you implement everything in the game? Because as I recall, there was something that you could type in.
X, Y, Z, Z, Y.
No. Something else that would open up the internal. You could get it to a point where you could alter the game by getting directly into a list that it was using.
Oh, like the buffer overflow or something like that. Like it. I don't know. That might be possible. There
was a way to cheat at it. Basically, it's like, oh look, I've opened up the insides of it, and I can just change it.
Yeah, no, I'm sure that there's a way to do that. This is, as far as I know, the earliest version that was ever published. And so if there was a bug like that, this probably contains it. I did not know about that bug, so I don't know how to check for it. But I bet if I typed in the right magic word in take or something, it would overflow something and overwrite some word, and I could modify things, or, I'm sure something like that is possible.
Well, I was playing it on a DEC System 10 in 1979, so I think it was a pretty early version.
Yeah, that would have been one of these early.
And it wasn't a bug, it was sort of a, admin mode where
okay.
It was intentional, it was just very well hidden.
I did not look at the source code in that level of detail. I mostly was just getting it to parse and compile. That is very possible that is in there, and I either didn't see it or did not know what I was looking for. X, Y, Z, Z, Y, you can definitely see hard-coded in there, though. That's pretty cool. And Clover, yeah. Clover is 6 letters, though, isn't it? Yeah. Oh, Plover, yes.
So the game's been ported to some other forms that might be easier to run in Python or JavaScript. Did you consider using those for this project, or was it more?
Absolutely did not consider running any fancier code. I don't need that fancy code. I wanted to go back to the original form as much as possible. But yeah, I know it's been ported all over the place. Like every system had a copy of Adventure starting like in the late 70s because it was such a popular game, and people like tweaked it and made it their own and like changed it, and you get things like Zork and stuff like that. But I wanted the original one because like if you wanted to play a copy of the original code as it is, like unless you boot up a PDP-10 simulator, you can't. Like there's nothing that has the original Fortran code running, essentially. So I was like, I want to run it as originally as you could run it. It's still waiting to take the lamp. Did it crash? Oh no, it's still just doing its thing.
Thank you for the talk. Quickly, what steps would you take to make this more performant?
There are many steps I could take to make this more performant. For one thing, profiling it like at all would be really good. Like I didn't even try. Yeah, there's a lot of loose threads, especially in the JavaScript part, where it's executing the bytecode, but it definitely does not have a lot of optimizations. Like I know, especially because I implemented a lot of de-optimizations into the JavaScript layer. In Python, like all integers can automatically expand to be arbitrary precision. But in JavaScript, everything is a double. So initially, the first implementations we had, we use integers as doubles everywhere, and that works great until someone types in 10 * 200, and then you get like some nonsense answer instead of what you actually want. And so then you sort of have to be really careful about when you switch between and which ones you use as indices, and that slows everything down a whole lot. So like probably like looking more carefully at logic like that would probably be a good place to start. I know that was a source of a huge slowdown, but necessary to get anything to work. Yeah, there's a lot of, oh, did I finally get I got the lamp. Yeah, there's a lot of places to look for optimization. If I were trying to like seriously do this and make it not a giant hack, yeah, that would be a lot of fun. What else was here? The keys. I need the keys. It'll run for a while.
Thanks a lot for your talk. I really love Python used forensically like this. It's a lot of fun.
Thanks.
Keeping in your spirit of being lazy, have you considered writing an AI to text your phone and have it solve the game for you?
I mean, you certainly could. I don't know. AIs are really tricky, right? Because you either have to make the algorithms very smart or you have to have a lot of input data for machine learning. And I'm really lazy, so I don't want to make a really smart model. And I don't have, like, machine learning would be really, I think text adventures are not a great setup for machine learning. I know that they have done some successful AIs for some roguelikes. Like there's like Angband has like Angbot or something like that, where it will automatically play Angband and sometimes it could even win. But I think that's more like the sophisticated algorithm approach rather than the huge machine learning data approach. But yeah, that could be kind of fun, but I don't know if a text adventure is the right format for that. Because like this is almost scripted. Like there's only a few parts where it actually will pull a random number, but other than that, everything is like you can follow the exact same thing and you can always win.
Right. Thanks.
Sure.
So it looks like that's it for questions. So let's thank Christopher one more time.